Now we'll work our way through the actual quiz questions. And what we have here is a paper machine. The rollers that press on the paper and smash it out are called calendars. Comes from the same Greek word as our word cylinder. Anyway, we have a paper machine. It's got a 1.5 horsepower, 1500 RPM motor. We want the paper machine to turn 600 RPMs. We're hoping for a center distance of about 19 inches, and we're using a number 25 chain again, so a 1/4 inch pitch. And we'll work our way through the steps in our cookbook. Beginning with finding the design horsepower by finding the service factor. Here's our service factor chart again. I have given you all these tables that we are looking at in 2 handouts which you can download. So you can have copies of these tables with you. Besides, you can also look them up in the PowerPoint here. So let's find the service factor. Looking through this alphabetical listing of stuff, there's paper industry, and here's paper machines. By the way, they misspelled calendar. Calendar, the roller, is spelled ER. Okay, so there's calendar, and you have an electric motor, so you have a type A. So you can probably figure out your service factor there. Now let's find the design horsepower. You have a service factor of 1.2 times a motor horsepower of 1.5. So 1.2 times 1.5. There you go. We're using a number 25 chain, so you have this chart in your handout as well. And let's now use this horsepower rating chart to select the small sprocket, the driver sprocket. So first, we'll find the RPM, and again, revolutions per minute is these numbers across the top. There's ours, 1500 RPM. That's this motor. Now, we'll find the horsepower that goes with that motor. There's our possible horsepowers. Down at the bottom of the slide, I note that when you did horsepower of 1.5 times a service factor of 1.2, hopefully you came up with a design horsepower of 1.8. So in our chart, we need to find a horsepower greater than 1.8. And the first one we come to that's greater than 1.8 is 1.82. So now we want to look in the column that has number of teeth in the small sprocket and find what number of teeth corresponds to our horsepower of 1.82. Yep, there we go. 30 teeth in the small sprocket, the driver. Now let's figure out the speed ratio. We have a motor of 1500 RPM, a paper machine of 600 RPM. So what's 1500 divided by 600? That's your speed ratio. And that turns out to be 2.5. If you have a ratio of 2.5 and you have 30 teeth in the small sprocket, how many teeth are in the big sprocket? What is 2.5 times bigger than 30? That's how many teeth you have in the big sprocket. Now, let's go through this exercise and figure out how many pitches of chain are in the chain that you're going to use. What is your chain length? So here's our formula again, and here at the bottom are the numbers that we have to work with. You found that the small sprocket had 30 teeth, the big sprocket had 75 teeth, and so far the center distance is going to be about 19 inches. So here are these things that we're looking for, what C, S, K, and D mean. All right, so start with C, the center distance. You're hoping for a center distance of 19 inches, and you're using chain with a 1/4 inch pitch. So you have 4 pitches per inch times 19 inches. How many pitches is that? Now let's figure out the S number. Total number of teeth, so 30 plus 75 gives you, what is your S number? Probably 105. Then we figure out the D number, the big sprocket minus the small sprocket. So we have 75 minus 30. We must come up with 45. And now we look up the K value in the table that corresponds to 45, and it turns out to be 51.29 for reasons we don't know. There are reasons, we just don't know them. Okay, so now you can plug the C, 76 pitches, the S, 105, and the K, 51.29, into this formula and figure out how long your chain should be in pitches. And if you get, and you need to round it to a whole number, of course, and if you get an odd number, then make sure you round it to an even number so that we do not have to use an offset link. Now let's figure out the lubrication method. Here's our 1500 RPM, and here's our, where was our horsepower we found was 1.82 horsepower for this particular design. So what category of lubrication do we land in? Ta-da! There it is.